Hello, everyone. I need you to open up your absolute value packet to page 10. Open up your absolute value packet to page 10. Okay, in this lesson, in this recording, I should say, we are finally going to talk about an introduction to absolute value. What is it? What is it used for? When are some times that you will see absolute value? After we talk about the introduction, we are going to talk about solving absolute value equations. Okay, so in the top of your notes on page 10, an introduction to absolute value, I want you to write down absolute value is the distance a number is from 0. So absolute value is the distance that a number is from 0. You probably remember this from pre-algebra. So if I put a point on the number line above 3 or on 3, and I asked you, what is the absolute value of 3? You would tell me that it's 3 because 3 is 3 units from 0. I give you another example using the notation of absolute value. This is the absolute value bar, which is around the number. The absolute value of -3 is +3. And again, because -3, which is right here on our number line, is 3 units from 0. So the absolute value of something is always positive. If you said to someone, I ran the absolute value of -5 miles, we know that that's going to be a +5 because the absolute value of something is always positive. It's the distance from 0. You can't run negative miles anyways. So anytime you're talking about distance, you're probably going to see absolute value. The absolute value graph, the parent function, looks like a V. So it kind of reminds me of a parabola, but it's a V. This is the absolute value parent function. The general equation for an absolute value function is y equals absolute value of x, and you have the absolute value bars around the x. Okay, so I want you to remember absolute value is the distance from 0. The number's always going to be positive because you're finding absolute value. I also want you to remember that the absolute value graph looks like a V because we're going to get to this in the last lesson, talking about how to graph absolute value functions. Okay, so let's do some examples. So number 1, what is the absolute value of -4? In other words, how many units is -4 from 0? I hope you say 4. Okay, absolute value of anything that's negative is going to be positive. Now the second one is kind of different. We have the negative absolute value of -8. So let's first drop down the negative in front of the absolute value bar because that negative's not going to go anywhere. And let's focus on the absolute value part, what's inside it. The absolute value of -8 is +8. So all we're going to do here is drop down that the absolute value of -8 is +8. That negative that was in front, we dropped down, and again, that stays like that. If you have a negative in front of an absolute value sign, you have to keep it there. You cannot get rid of it. Number 3, the absolute value of 12. In other words, how many units is 12 from 0? It's 12 units. Okay, let's look at number 4. Okay, 4 through 6 now have imaginary numbers. So we're going to talk about how far imaginary numbers are from 0. I need to explain one thing to you before we do talk about this. We're going to graph imaginary numbers here in a second or a couple minutes. When you have a coordinate plane, the imaginary numbers are always along the y-axis. The real numbers are always along the x-axis. Okay? So you are able to plot these on a graph even though they are imaginary. So if we asked, what is the absolute value of -2i? We could plot those on a graph, okay? The absolute value of -2i would be, if I could go down here, it's imaginary, so it would be down 2 units. So how many units is that from 0? It's 2 units from 0. So if you're finding the absolute value of something that's imaginary, same thing, it's just along the imaginary axis when you go to graph it, if you have to graph it. The absolute value of 3i is 3 because 3i, which let me erase this, if we plotted 3i, it would be up 3, okay? It is 3 units from 0. And then the last one here, the absolute value of negative 12i, that would be down underneath on the y-axis, is 12 because that is 12 units from the origin. In other words, it's 12 units from 0. Okay, so the absolute value of something is your distance from 0. It's always going to be positive unless there's a negative in front. Okay, number 7 and 8 are different here. So let's take a look at 7 and 8. Okay, anytime you see the absolute value of a real number and an imaginary number, this is called a complex number. Okay, so the first thing you have to do is put on your graph, label the axes, imaginary and real. So first thing you want to do is label the graph imaginary and real. Okay, we then need to plot where this point is, okay? So we know 3 is the real, so we're going to go over 3, okay? We're then going to go up 4 because 4 is the imaginary. So over 3 because that's the real number, up 4 because that's the imaginary, okay? We're going to draw a dotted line here from the point to the origin, and we're going to make it look like a triangle. Now we're also going to label what we just plotted. We know 3 was the real, 3 goes here, 4 was the imaginary, 4 goes here, okay? So if we're trying to find the absolute value of 3 plus 4i, we have to find the distance from 0. So to find the distance from 0, let me get my highlighter, we have to find that distance that I just highlighted in green, okay? To find the distance in 0 from a right triangle, we use something called Pythagorean's theorem. I wish I was in class with you guys. I'd ask you if you remember this. You've heard about this before. I hope that you remember at least the name of it. But Pythagorean's theorem is something that we use to find the distance, and you can only use it with right triangles. So what we need to do here is find the distance from 0 because that's the absolute value of complex numbers. Pythagorean's theorem is a squared plus b squared equals c squared. Okay? This side is a, this side is b, and those can be interchanged. The hypotenuse, which is the distance from the right angle, is always c. Okay? So that hypotenuse there is always c. So let's find the distance from 0. A is 3, so we have 3 squared plus b is 4 plus 4 squared, which is equal to c squared. Okay, so 3 squared is 9, 4 squared is 16. Okay, so that is all equal to c squared still. Next step, we need to add the 9 and 16. So we have 25 equals c squared. Now, that is not solving for c, so you need to ask yourself, how do I get rid of c squared? You need to take the square root of both sides to get rid of the square. Okay, that's something that you probably haven't learned yet. So just want you to remember, to get rid of a square, you take the square root of both sides. The real reason behind that is when you take the square root of both sides, it's really to the 1/2 power. And you can actually think of this from our first lesson. Okay, it's a perfect square. So the square root of c squared is just c to the first. So they cancel. This actually allows us to solve for c. So the square root of 25 is 5. Well, that's the answer. The absolute value of 3 plus 4i, in other words, the distance from 0, okay, is 5 units. So that one works out nicely. They don't always work out that nicely. Okay, so let's try another one like that, but where there's a negative in it. Okay, and remember, we're just finding the absolute value of a complex number. Okay, a little bit more work involved than just a real number or an imaginary number. All right, so number 8, we have 6 minus 3i. First thing I want you to always do on these problems is plot the imaginary and real. Write down what axis is what. Okay, and now we have to plot it. So we know that the real number is 6. So we're going to go over 6, 1, 2, 3, 4, 5, 6, which is right here. And we're going to go down 3, 1, 2, 3, because we know that the imaginary number is -3. Okay, this is 3, this was 6. I'm going to make the dotted line. Okay, and let's draw our triangle. Okay, so 6 units was the real, 3 was the imaginary. That's why we went down. The dotted line, which I'm going to highlight again, that's going to be the distance from 0, okay, which is what we have to find. I recommend going ahead of me or pausing the video on this so you can find what the distance is going to be from the origin. Okay, hypotenuse, which is opposite the right angle, okay, that's always C. So I know that this 3 was a negative. I'm going to put that negative there. So we still need to use Pythagorean's theorem to find what the absolute value is. Okay, so we have a squared plus b squared equals c squared. If we use -3 as a, or even if you use it as b, regardless, please put your parentheses around what a or b is, so you know that that negative goes with the squared. Plus, we'll say b is 6, so 6 squared, okay, all equal to c squared, which is our hypotenuse. -3 squared is +9, plus 6 squared is 36, all equal to c squared. 9 plus 36 is 45, which is still equal to c squared. Now, we're coming down to our last step, just like we did in the previous problem. To get rid of c squared, square root both sides. This goes away. It becomes c to the first power, which allows us to get c equals the square root of 45. Now, we're not done. Okay, so for those of you that did not like simplifying radicals, when you use Pythagorean's theorem, we have to simplify radicals again. So your answer is not done until it's completely simplified. So you need to ask yourself, what is a perfect square that goes into 45? Okay, I hope you thought of 9. If you didn't think of it that quickly, that's okay. 9 times 5 is 45. 9 is a perfect square, so I'm going to circle it. The square root of 9 is 3. So we know that the distance from 0, which is the same thing as saying the hypotenuse, okay, is 3 square root of 5. And I'm going to write that back up here. The absolute value of the complex number 6 minus 3i is 3 square root of 5. So just like we did in the first lesson and second video, you need to make sure that you are simplifying the radical completely. Do not change it to a decimal. Okay, so I will have a short assignment on this. This is the introduction to absolute value, how to find it, how to simplify, okay? Remember, it's the distance from 0. If you need to watch this part again, please watch this again before you move on. I am now moving right into solving absolute value equations, okay? This is a pretty straightforward lesson, but I just want you to see, well, when will I use absolute value? When will I see it? Okay, we're going to do this with equations, inequalities, as well as with graphs. So you'll see it with three applications that you'll see in this note packet. Okay, so the absolute value equation, this is page 11 of your notes. Okay, I want you to write down next to it, ax plus b is equal to c, comma, where c has to be greater than or equal to 0. So the absolute value equation is the absolute value of ax plus b equals c, where c has to be greater than or equal to 0. If the c in this equation is not greater than or equal to 0, it's not true. There's not going to be a solution. You cannot take the absolute value of something and get a negative number. So this c in this equation always has to be 0 or more. If it's not, the answer is going to be no solution. So if we look at the examples, it says solve each absolute value equation if possible. Okay, so the if possible part means, if we look back at the general form, When it's in this general form, that C has to be greater than or equal to 0. It has to be positive. Okay, so this, you're going to probably find this really, really simple, okay, once I explain this. So let's look at just a basic example. The absolute value of x equals 3. You always want to start by asking yourself, is it in the general form? So is it the absolute value of something equals a number? Okay, this one is. So you want to split it up then into two separate equations, getting rid of the absolute value sign. One of them is going to be x equals 3, getting rid of that sign. The other one is x equals negative 3. So you're always making this number that I'm circling, one positive, one negative, and you're getting rid of the absolute value sign. So that's it. X is 3 and x is negative 3. If you go to plug it back in, the absolute value of 3 is 3. If you go to plug this in, the absolute value of negative 3 is 3. So if you go to check that, it should always work. Okay, let's go to letter B. The absolute value of C is 15. So ask yourself, is it in the form the absolute value of something is equal to a number? It is. So split it up, get rid of the absolute value symbol, make this 15, one of them positive and one of them negative. So your two answers there are 15 and negative 15. If you plug them back in, the absolute value of 15 is 15, and then the absolute value of negative 15 is positive 15. Okay, letter C. The absolute value of x is negative 5. So ask yourself, is it in the form the absolute value of something equals a number? Is this number greater than or equal to 0? Okay, I hope you're saying no. Since that number is not greater than or equal to 0, it's no solution. If you don't understand that, here's why. If you try to take the absolute value of something, you cannot get a negative number. Okay? This number that I just underlined again, that cannot be negative. So if you ever see the absolute value of something that's negative, there's no solution. Okay, let's go to letter D, then I'm going to start skipping around a little bit. Okay, letter D, we have the absolute value of r minus 7 equals 9. So is it in the form absolute value of something is equal to a number, and that number is greater than or equal to 0? Okay, it is, and we know that that 9's positive. So we start by splitting it up into two separate equations, get rid of the absolute value symbol. One of them has a positive 9, the other one has a negative 9. Okay, and I'm going to draw a line down the middle here so we don't get confused. Okay, so now we have our two separate equations that we need to solve. So let's solve one at a time, and then we'll go back and check our answer to make sure this works. So add 7 to both sides in the first one to get r by itself. So in the first one, we end up with 9 plus 7, which is 16. So I'm going to circle that because r is 16. Second one, also add 7 to both sides to get r by itself. Negative 9 plus 7 is negative 2. So our two answers are 16 and negative 2. If we take 16 and plug it back in, 16 minus 7, I'm back up here, okay, is 9. The absolute value of 9 is 9. Okay, if we take negative 2 and plug it in, negative 2 minus 7 is negative 9. The absolute value of negative 9 is positive 9. So that works as well. Always go back and check to make sure both those numbers work. Okay, I'm going to jump to letter G. Okay, I'm going to jump to letter G. Okay, letter G, we have the absolute value of a minus 2 equals negative 3. So first ask, is it in the form the absolute value of something is equal to a number, and that number is greater than or equal to 0? Okay, I hope you're saying no, or I hope that you realize that since that is a negative, it's no solution. You cannot take the absolute value of something and get a negative number. Okay, distance is not going to be 0. So that's not possible. You can't find a number that works for that. Okay, on that page, I want you guys to go back and do letter F. So circle letter F. I want you to do that one and show letter F to me when you come see me to get your assignment for this lesson. Okay, after you circle letter F, turn your notes over. And I want to do some of the harder ones. So let's take a look at letter H. Okay, I just want to do, I think, 2 of them on here. Okay, so letter H is kind of different because this is not in the form absolute value of something equals a number. So we first need to get everything to the other side except for what's in the absolute value symbol. Okay, so we need to take this -5 and we need to move this to the other side. So first step, we need to add 5 to both sides. Excuse me. 3, I'm going to rewrite. Absolute value of 2x minus 7 equals 9. All right, so we move the 5 over, but we're still not in the form absolute value of something equals a number. And the next thing, and I don't want you to get confused on this, the 3 in front of the absolute value symbol, okay? How do you get rid of that? Now, I wish we were in class and I could ask you, but that 3 in front, you do not distribute, okay? The absolute value notation, do not treat like parentheses. You have to get rid of that 3, but you don't distribute. So to get rid of the 3, we divide both sides by 3, okay? This 3 goes away because 3 divided by 3 is 1. So we're left with 2x minus 7, the absolute value of it, is equal to 3. At this point, you're in the form absolute value of something, in this case, it's an expression, is equal to a number, and this 3 is greater than or equal to 0. So now we split them up, get rid of the absolute value symbols. We make one of the 3's positive and one of them negative. So on the left, we have 2x minus 7 equals 3. I'm going to draw my line so we remember we have 2 equations. The other one, 2x minus 7 equals negative 3. Okay, the one on the left we're going to solve. So add 7 to both sides. Get that to the other side. We have 2x equals 10. To get rid of the 2, divide both sides by 2. So x equals 5 is one of our solutions that makes that initial absolute value equation true. Second one, add 7 to both sides. We have 2x equals 4. And then to get rid of the 2, divide both sides by 2. We get x equals 2. So x equals 5 and x equals 2 are the 2 solutions to this absolute value equation. I'm not going to do this again, but if you take 5 and 2, and if you plug them back in for x, they are both equal to 4. They both work. Okay, let's just start one more of these together, and then I'm going to have you try one on your own. So let's start letter I, okay? So letter I, first thing you want to ask yourself again is this in the form absolute value of something equals a number? It's not, so we have to add 5 to both sides. We have 4, absolute value of t plus I is equal to 24. So then the 4 in front of the absolute value symbol, remember, don't distribute that. You never distribute with absolute value notation. So divide both sides by 4. That 4 goes away. Absolute value of t plus 9 is equal to 6. So now it's in the form absolute value of something is equal to a number. That number, which in this case is 6, is greater than or equal to 0. So I want you to finish this, split them up into 2 different equations, get rid of the absolute value symbol. One is positive, one is negative, okay, and circle your 2 answers. So I want you to show me that one, and I also want you to do letter L. So finish I, and then do letter L, okay? I need to see, so basically you have 2 problems to show me, and then finish letter I. Okay. This ends the absolute value lesson, which included the introduction as well as solving absolute value equations. So please come see me for your assignment so I can give this to you, and then the next video will be due the next week. Okay? So I will see you for your assignment.